Welcome back everybody to part 2. If you're enjoying this series, please remember it is funded almost entirely by good folks like yourself over on my Patreon. If you're finding this series useful and want to get early access to new episodes or just want to see this work get bigger and better, you can hop over there and make all those things happen. Right, today we're going to be animating the player character. Last episode we made a big deal over the structure of our player sprite being split into 4 directions like this, and today is we're going to put that structure to work. Now, other than actually getting our player to face the correct direction, because our player sprite doesn't actually have anything to animate in it, okay, it's just an idle sprite, facing to the right, facing up, left, and down. So we're going to bring in the Run Sprite for the player as well, so we can show that in action as well. So I'm going to press Alt-S, first of all, just to make a new sprite, or Command-S, or whatever it might be on a Mac, I'm not entirely sure, just to get as a new sprite that I'm going to call S-Player-Run. Capital P, capital R, and then I'm going to click Import, and back in our big ARPG assets folder, I'm going to find somewhere in here, it's one of the longer ones I think, S-Player-Run _ strip 32, and bring that in, and because of the strip 32 thing, when I bring it in, boom, it imports all of our frames like that. So as you can see, similar to how this was set up, facing to the right, up, left, and then down, this Run Sprite is set up in exactly the same way. So if you want to make your own, this is the structure you need to use. Each animation is 8 frames long. It doesn't matter how long the animation is, as long as each direction has the same number of frames. That is very important. So it's 32, so each one is 8 long. So you can see we've got an 8 frame running to the right animation, an 8 frame running up animation, left and down. Okay, if I play that, he just sort of like runs and sort of spins in a circle, similar to how the player sprite just sort of spins in a circle, right? So once you've either brought that in or made your own or whatever, you can see it's exactly the same sizes as well. Like oh no, okay, this one's actually 1 pixel wider. 1 pixel wider than the original sprite was. Not that it matters, I probably needed to do that in order to fit like some of the, like, yeah, I think this like fully, oh no, that looks like it would just, I don't know. I don't know why it's 1 pixel wider, but it doesn't matter either way. It's the same size, like roughly anyway, taking up the same sort of space. The dimensions don't matter too much as long as we get the origin in the correct place. In order to do that, you may have to spend some time if you're making your own, making sure they all sort of line up. Just the same way these ones do positionally in the frames. But the main important thing to get right here is when you bring it in to get the origin in the exact same space relative to the image. Not necessarily the exact same coordinates if it is a different size thing. I think ours works out as the same position. But just make sure that the origin lines up. So using some sort of visual reference on the image itself is handy. So as you can see here, the origin is like right in between his legs, like in the bottom center down there. And on this facing to the right one, it's like on the middle of the 3 pixels here. So like the middle bottom pixel of the foot there, okay? So just make sure we've got that in the same position here. So this is the very first frame of our animation here. So if I bring that down there, onto that exact same pixel there, because it's like the exact same frame starting off. That's our sort of starting position. So make sure that's in the same position there. And if we go to up, we can see that's in the same position there. So we can check to make sure that they are lined up correctly. If they're not lined up correctly, then when you start moving around, you're going to have some weird like jumping. Like it'll appear like your player like seems to teleport a little bit as suddenly his origin becomes a little bit offset or whatever when he swaps to this animation. But the origin is all we need to do here. We don't need to do anything with the collision mask. We can leave that on whatever the automatic is because we're not using it. We're just using whatever the collision mask we set up in our original player sprite was. Okay, this manual kind of rectangle down here. That's the only one we're worried about. So this can be left as whatever default it comes as, okay? So I'm going to close both of those down now. And the next thing I'm going to do is open up our player sprite, not a player sprite, our player object, sorry, and go into the create event where we're going to add a few new variables to control some more stuff to do with the player. What I'm going to do is add a couple of sprites to store the names of these sprites. That might seem a little weird because we can obviously reference the sprites themselves in code. But what I want to do is put those sprites into a into variables. So I'm going to write sprite run equals s player run semicolon, and sprite idle equals s player. So you might wonder why on earth it's worth doing that, because, you know, if we can refer to this in code anyway, why do we need to just stick this in a variable? And the clue is kind of in the name. Okay, this is a variable. It means that we can change this on the fly. So if, for example, later on we wanted to change our running and idle sprites to be something else, say, I don't know, we change character that we control, or I don't know, he's wearing a hat, or you know, something along those lines, we can easily do it just by later on in our game just being like, oh, sprite run now equals s player run with hats, or something like that, right? Just gives us a bit more flexibility. I actually can't remember at this point in time if or exactly when I might do that throughout the series, but it is nice to have that flexibility regardless. So it's a good idea to do this either way. Let's just maximize this briefly, just a nice habit to be in, really. And I'm going to add one more variable to this, which is local frame equals 0. Now, some of you used GameMaker a little bit, you might be aware of image index, which is a built-in variable that tells us what frame of a particular sprite we're using. But what we're doing is, because we have this unique setup here where we've actually got kind of multiple animations within a single sprite, where if we were on, say, this sprite here, the third sprite, the third frame of our up running animation, this would be image index 11, or I think 10 if it counts from, yeah, it counts from 1 there. So this would be image index 10. But we want to know what frame we're on relative to our current animation. So when we want to show this animation, we want to know that this is the this would be 0, 1, 2, right? This would be local frame 2. So that's what local frame is going to store for us. It's going to tell us what frame we're on relative to which directional animation we're playing, okay? So again, rather than this one being 16, it would be 0, and this one, rather than being 17, would be 1, and so on, okay? So those three things are all we need to add to the create event for now. So I'm going to right click and hit add/open event and go to the step event, bringing us back to here where we can see all of our movement code and all of our input code and stuff like that. And at the bottom here, I'm going to do a section for updating the sprite. So update sprite index. This should be fairly familiar to you if you followed Tim, a platformer tutorial, and is generally what we do, right? We've gathered our inputs for a frame, we've done any movement and stuff like that, and we know what kind of state our player is in. And based on that, and based on whatever current conditions our object is currently in, after deciding what our inputs and stuff are doing, we can set the appropriate sprite, okay? We know if we're moving, we know in what direction we're moving, so now is the appropriate time to set our animation up. Alright, so first thing I want to do in here is we need to store what sprite we're currently on. That's going to be important because it's going to help us tell later on if we have changed animation, this frame. So I'm going to type var underscore old sprite equals sprite underscore index. Sprite index, obviously storing whatever sprite we're currently on, and just sticking that in a variable so we can remember later on what sprite we were on. If you're very new to GameMaker, you might be wondering what var is, so just very quickly I'll go over that. That's essentially declaring a temporary variable at the end of this script that we're running now. This variable basically be discarded, okay? So stuff we don't need to remember or look after, okay? Very useful. I always put this underscore in front of my vars, my temporary variables. Helpful to distinguish them from any variables I might have declared elsewhere. So things like in my create, like I might have, I don't know, maybe I for some reason have a variable called old sprite in here, and you know it's helpful to make sure I don't accidentally conflict with those and so on. All right. Just my naming convention. You can do whatever you want. Next, I'm basically going to work out what it is we're doing, and therefore what it is we want to, how we want to animate. So if input magnitude does not equal 0. Wrong type of bracket there. Direction is going to equal input direction, and sprite underscore index is going to equal sprite run. Okay, that's the variable that we put our splayer run into. And direction is it is a built-in variable that you can use with speed. So if you set a direction, you set a speed, your object will move in that direction and so on. But otherwise it's just a variable that stores a number, and it's called direction, so it's useful for us to store our input direction in. The reason for that, the reason we can't just use input direction to determine what direction we're going to use in our sprite later, because if we do, you got to bear in mind input direction is changing every single frame, and if we're not pressing any direction, then input direction is going to set itself to be like 0, right, facing to the right. So we don't want to have it so that when we run to the left and then stop running to the left, we instantly turn around and face to the right. Okay, unless we press to face to the right. Okay, so that's why we're going to set our direction only when we have an input magnitude, and we're going to store it in a different variable so that we always have a direction even when we're standing still, because our direction might be important when we're standing still, right? And so our sprite index is just being set to sprite run because we know we have an input magnitude. It means we're trying to move in a particular direction. Now you could use speed for this, so you could like add your speeds together and see if like they add up to more than 0 or whatever, and decide to do it that way based on whether or not you're moving. I prefer to actually animate based on inputs rather than animate based on the actual end result, because if we are colliding with a wall, say we're against the wall on the left and we're pressing the left arrow key, I prefer in a game when the character still animates and is trying to run, rather than I'm pressing left against the wall and because I can't move into the wall I therefore don't animate, I just stand still. I prefer to keep trying to run, so I'm still getting that input feedback as a player. You can do whatever you like. You could base this on your speed if you really want to. I prefer to base it on the input magnitude and the input on what we're trying to do. Alright, so if this isn't true then, and input magnitude is 0, then we want to just have our idle sprite playing. So else sprite index equals sprite idle. And last of all, if old sprite does not equal sprite index local frame equals 0. Okay, so here is these two lines are basically what's deciding which animation we're going to play. Okay, it's just if we're moving in a direction, or we're trying to move in a direction rather, where we've got an input magnitude, then set ourselves to the run sprite. Otherwise, set ourselves to the idle sprite. And old sprite stores whatever we had at the beginning. So if old sprite is still, if our sprite index is still the same as old sprite, then we know we haven't changed animation. But if it's not anymore, then we know we have changed animation. Okay, it's either gone from run to idle or from idle to run. And if that's the case, I'm going to set our local frame to be 0. And if you remember, our local frame was our frame relevant relative to the animation within the sprite. Okay. The reasons I do that, firstly, I like that visually. I prefer visually, like if we're like running along and our animation is here, and then we go back to idle, and then we go back to run, we start from the beginning of the animation again. But also it helps us a little bit later on. It makes sure that if we have, say we're on local frame 8 of an animation, and we change animation, and say our idle sprite had like, I mean, I know our idle sprite doesn't actually animate, but say our idle, say it did, and it had like 3 or 4 frames of animation, and we went from local frame 8 to suddenly in sprite idle at local frame 8, that would be in the wrong place, and it would be something we would have to account for later on, and it just saves us a bit of a headache, okay, just by cleanly resetting this every time we change animation. And we'll be doing this generally throughout the game, or whenever we need to change animation, just setting local frame back to 0. Just saves us a headache of having to worry about what to do with it. Speaking of saving us a headache, actually, one more thing to mention about this direction variable that we used up here. Or, why not use like, I don't know, just object direction? Why not use like our own? Why not use our own variable for that? Why are we using the green built-in one? As I said earlier, one is just because it's there and it doesn't do anything otherwise, because we're not using the built-in speed variable, so it doesn't do anything with that. But one thing this does do by itself, which is quite handy and saves us hassle, is it automatically wraps an angle. So if we were to put a number into here bigger than 360 or less than 0, it would automatically wrap it around to be the correct value. So if we put in like 400 into here, that's obviously 40 more than 360, so it would wrap around and give us back an angle of 40. Okay. Which is very handy, just saves us having to worry about that ourselves and what happens when our angles go over 360 and that kind of thing. All right, so we know we're always going to have a value between 0 and 360 in here, which is very useful for us later on when we're calculating angles and stuff like that. Okay, so now this sets our animation appropriately. It sets us to the right sprite, but our animation speed, I believe, is still 0, and the first frame of each of these is exactly the same still. Okay, it's just that starting standing frame, and we've got this complex setup in our sprite. So how do we animate any of this? Like, because if we play this animation at any speed, it's just gonna go in a circle, right? So how do we combine that with our direction and work out which area of the animation to play, and play our animation manually, not using our image speed? To do this, we're going to actually create a script. We could just write the code down here, like following update sprite index, but this is going to be something we're going to do quite a bit throughout the different states when we come to implementing the player state machine and so on. All our animations are going to be handled in the exact same way, so we're just going to write a script so that we only have to write this chunk of code once, and we can just keep putting this script where we need to, and we're going to call this script right here. But first of all, we actually need to make the script, so I'm going to right click on scripts and hit create script and call this player animate sprite. And I'll just leave a comment on the top. What we're going to do in here is update the sprite. This first line is a little bit of a doozy, so bear with me while I try and explain it. I'm just going to write it out first. var underscore cardinal direction equals floor, open bracket, open bracket, open bracket, direction, div 45, close bracket, plus 1, close bracket, times a half, close bracket, semicolon. Right. If you're wondering how on earth did I come up with this, it was just the first sequence of, I'm sure there's other ways, probably better ways of doing it. It was just the first bit of maths I could come up with that got us from 360 degrees down to numbers between 0 and 3 in the vague arrangement that I wanted. Okay, you can do whatever you want. There's other things you could do here to get the right one. And people have asked as well about if the system would scale up to support like 8 directions and stuff like that. Absolutely would. You would just have to find a different formula for your cardinal direction and kind of work out yourself using these various different tools, like how to get to the values that you want. The rest of this script will pretty much scale for any number of directions to the best of my knowledge. I've not tried it with 8 directions or more, but the way I've written it, it should be it should scale up. It shouldn't actually matter. So the next line is var underscore total frames. This is going to work out how many frames we have in a particular animation within the sprite. Okay, so for player run, 32 frames in this sprite, and if we divide that by 4, we're going to get 8, which is the number we have in a particular animation within the sprite. Okay, so total frames is going to equal sprite get number. Weird looking function, but it returns the number of frames within a sprite. Sprite index and divide that by 4. So again, yeah, if you are scaling this up, you'll obviously have to change that number to however many number of directions you've got, but that's more or less it, okay? I think that actually is the very last thing we need for that. Image index is going to equal local frame, so we know that's 0 at the moment, plus cardinal direction, in brackets here, multiplied by total frames. So this does a lot of heavy lifting. Whatever local frame we want to be on, say we want to be on frame, can't talk today, frame number 2 here, so 0, 1, 2 of our first facing to the right animation between 0 and 8. So our local frame is 2. To get our image index, we take that local frame 2 and we add it to whatever our cardinal direction is, in this case 0, multiplied by the number of animations, the number of frames in the animation. So each one of those is 8, so that'll be 0 times 8 plus 2 gives us an image index of 2, which is this one. Obviously that's a bit different because it's the very first one, but say we want this frame of our facing up. So we know we're facing to the we're facing up from our direction, and our cardinal direction is going to be 1, okay, from 0 up to 1. And this is going to be local frame 0, 1, 2, 3, 4. So we're going to have 4 plus 1 times 8. So 8 plus 4 gives us 12. And if we check that, that's current frame 13. So from 0 to 13, that is image index 12. Okay, so that gives us the correct one. That's pretty much that's the magic line. Okay, that's the thing that basically does all the heavy lifting of this and works out, you know, which actual frame we need to be on. And then all we need to do to animate is, instead of incrementing image index by our image speed, is we basically increment local frame by that instead. All right. So we do that by doing local frame plus equals sprite get speed open bracket sprite underscore index divided by and whatever our frame rate is. In this case, it happens to be 60 frames a second. Okay. We will replace that with a macro a little bit later on, in case we ever want to change our frame rate, so we don't have to come into all of the scripts and do it. In fact, let's do that now. Let's get that out of the way. I'm going to make a new script very quickly and call it macros in all caps. Okay. I'm going to move it to the very top of our scripts list, and I'm going to type macro frame rate. I always type macros and constants in all caps, okay, just to clearly distinguish them as constants that are fixed and can never be changed. And it's going to be 60. No semicolon on the end of that. It's important with macros, okay? So if you've never made a macro before, you can, it's not really the full story, but you can think of them for now as constants. And they are baked into your game at compile time. Okay, so you don't have to worry. Basically what it does is, for every macro you have, so for frame rate 60, it's going to go through all of my code and replace anywhere that I've written frame rate with 60. Okay, that is actually how macro works. Okay, it's going to find everywhere I've written this and replace it with 60 when I compile the game. Very, very handy, because then that means, you know, I can include this frame rate in 1,000,001 places throughout the game. And if I ever want to change the frame rate, I just come back to this macro script and just change this number here. Okay, quite useful. And I don't have to call this macro script anywhere. Don't have to call this anywhere in the game. Okay, just having it exist in the project, this will all get compiled in. Okay, so you don't have to worry about calling it. That's why I just have them all in one big script called macros. All right. We'll get a lot more things added to this as we go throughout the project, but I may as well kick this off early now so you know how it all works, and we don't have to come back and edit it all in later. So I'm going to change that now from 60 to frame rate. All right. Okay. So sorry for the quick distraction there, but I think it was important to get that in and get that set up. ahead of time. So yeah, all we are doing here, just to remind you, is animating by, instead of increasing our image index, we're just increasing our local frame, and using that local frame along with whatever direction we're facing and how many frames there are per animation to work out what the actual image index should be. So we never animate this via image speed, ever, like via GameMaker's default system of animating, ever. We just animate by incrementing our local frame, every single frame, by whatever image index would have increased by if we did have an image speed, all right? Which is whatever speed we've set in the sprite itself. In this case, I guess player run, I think, is 15 frames a second. And then, you know, dividing that obviously by frames, so it's increasing it by the correct amount per second. So 15 divided by 60, increasing it by, you know, a quarter of a frame every quarter of a frame every step. That's what we want in order to therefore increase by 15 frames a second. Okay, so that's animating and that's controlling our image index. The only other thing we need to worry about now is what we do when we finish the animation, because if we just continue to animate like this, it's all well and good to start with, it'll start us in the right place, but then what happens when we get to the end of an animation? We're just going to roll on into the next one, right? And it's still going to animate in the same way. So we need to manually deal with actually looping our animation and ending the animation. So to do that, I'm just going to leave a comment first of all. If animation would loop on next game step. And if that's the case, then we're going to loop our animation. And we can do that just by subtracting this total number of frames. They still haven't changed color yet, that's really weird. By subtracting the total number of frames of a given animation, which is 8, from local frame. So that'll wrap us back around. Because then when we're here on local frame 0, and we get to here, we just subtract 8 and we're back to here again. Okay? Simple as that. So if local frame is greater than or equal to total frames, animation end equals true. That's something we're going to use a bit later. It's handy for us to know generally for lots of different reasons when an animation has finished. Not in this particular case, we're just going to loop it when we're running. It doesn't really matter to us. But because, as I say, this is a script that we're going to use throughout the game to do various different animations. When we're doing an animation that we only want to play once, it's handy to know when the animation would finish. So that is going to be a variable that we're going to set. We don't have to define it elsewhere for now because we are going to define it here as either true or false in the script itself, so don't worry about going back to your create event for now. And local frame, as I said before, this is going to be minus equal total frames. Okay, so that makes this compatible with a sprite with any number, as long as I say, each direction has the same number of frames in it. So it's like, this cleanly divides by 4 or divides by however many directions you're using. This could be a 3-frame animation or a 10-frame animation. It could be any amount, okay, as long as each direction in one particular sprite has the same number. So it scales and it's fairly modular and will work with lots of different situations. Else animation end equal false. Alright, so we know whether or not an animation has finished at the end of this. As I say, not useful now, but will be useful a lot later on. I'm just going to close this down and reopen it and see if... No, I have no idea why these aren't turning yellow or whatever. This one hasn't even changed blue. GameMaker can be weird about that sometimes. Especially in scripts. I don't know what that's about. But don't worry too much. As long as you've written it correctly, don't worry massively. If you can see that you've written it correctly, don't worry if, like mine, it hasn't changed color as it should. Hopefully by the time you're reading this, it's been updated and fixed, and I don't know, maybe that's a bit better in your version of GameMaker now. Who knows? Anyway, that's really all there is to it. So I'm going to come back to our OPlayer object, come back to the step event. I suppose I could have just clicked this tab up here, but a force of habit. Down here, so I called this update sprite index because that's what we're doing, setting the correct sprite, and then in order to know what frame we're on, we're updating our image index. We're doing that by calling this script player animate sprite, open bracket, close bracket, semicolon. And that's a lot. So assuming I haven't done anything wrong, I'm gonna run the game now. We've got our player as before, and when I start to move out, we animate. And when we stop, we stop. And that's all built from 2 sprites that allow where we would normally have we would normally have 8 sprites for this, right? We've accomplished with 2 sprites what a more basic implementation would accomplish with 8 by having all 4 directions in both of our 2 sprites. Very, very handy because we're going to do lots of different animations for the player throughout this game. And if we had to do four separate sprites for each one, our sprites would become very huge and unwieldy very quickly, especially if we had to keep making modifications to them and like the size or collision box and things like that. So it's very helpful. So I know this is developing quite slowly. This is episode 2, and we're only just gone to animating the player in a black space. But as you can hopefully see, we are starting to set up systems that are going to make doing stuff later on lots easier. Okay. So it is worth it. So it may seem like a slow burn to begin with, but I promise you doing all of this slow setup is worth it for the eventual game that we're going to make. Thanks guys, that's it for this one. Next time we're going to be taking a look at basic collisions. As I say, we're building this up slowly, but we are getting there bit by bit. I am hoping to put these out weekly now in the new year. We'll see how it goes. I don't expect I'll be able to make that 100% like every single week, a new episode. But that's kind of my goal. That's what I'm aiming for. We'll see how it goes. Thank you, as always, to all of my Patreon supporters. If you want to get access to the source code for these episodes, you can either go down and make a one-time payment below, or all of my patrons already have access to all that stuff. So you could go and become one of them. And you can also get early access to these videos every week. See them a week before everybody else does. And just enjoy the knowledge that you helped make them happen. That's always cool too. Thank you, special thanks in particular, and in no particular order, as always, to Army Armbuster, Arrow Barbarian, Bailey Raid, Bowser the Dog, Bertie T, Cabbage Pants, Dakadondago, Dark Rider 0318, Do What Do Be, Frederick Habetler, Gargoyle Drake, Hanu Kusi, Hare, Hyungjin, James L. Anderson, James Siggins, Jason, Christopher King, Leo, Max M, Nathan Wilson, Owen Morgan, Pixel Mush, Rene Dam, Robert Churches, Rovan Darlan, Run, Rupinder, Schaefer, Scott Matthews, Samian Yayalegaglo, Stephen Hagen, T. Lesson, Travis Womack, Tyler Hubble, Victor Stewart, Vil Vertanen, Zephyr Flame, and Zinan May. Thank you all very much, and thank you for watching. Cheers guys, catch you all next time.